So now, let's talk a little bit about data gravity. Yes, it's a little bit of a marketing term, I apologize, but it's a really good term to describe the problem. It's simple. If I have a lot of data and I put a lot of data somewhere, that's going to dictate my ability to interoperate with that data. And so, for example, if I have a lot of data in my local NAS environment, but I really want to use Google Compute Engine, for example, to do some overflow, secondary analysis of some sequence data output from a core facility, and I want to run that up there. Well, I'm limited by the fact that all of my data is sitting down in my data center, and I have to make some choices. And by the way, I mean, unless you are inside the Google data centers, you have the reality of latency. So I'm going to have to make a connection to Google. I'm probably going to do that with hopefully a nice private link, a 1 gig private link or something like that, depending on what your budget can sustain. But even there, do I have enough bandwidth on that link? So some people maybe don't yet have the budget to do a nice peer-to-peer connection with Google, although if you can, I highly recommend it. But if I'm going over the internet, for example, is that enough bandwidth for me to copy up FASTA files, very large FASTA files, in a reasonable amount of time that I can then go and run my pipeline and get things done? And that latency, combined with just simply the large dimensions of the files themselves, they both conspire to create a cumulative problem. Because remember, all of the data is back on-prem. Each worker node that comes online in Google is independently going to go and make, for the sake of argument, NFS, range requests for data directly onto the NAS over that WAN. And that's an unacceptable level of latency, frankly, for performance purposes. The data access layer, and basically, just to keep it short and sweet, it's caching in the cloud, if you will. It provides performance and access to critical data that you keep on-prem, but it's different. It doesn't copy all of the data up there. It's actually going to allow you to retrieve only the data that you're working with and only the data that those particular nodes are going to ask for. And so what does this do for you? It basically reduces the cloud latency because it's only going to, like if a node comes up in Compute Cloud, it's going to ask for a range of bits. It's going to, the caching layer is going to go down and get that data, and it's going to put it in the cache for all of the nodes to access. So the first hit is the last hit that you need to get to that data. The data access will only cache what was requested, so you don't have to load the entire data set. You don't have to worry about that anymore. And ultimately, that's going to reduce hits on the network itself, which means that once that set of data is up there, if the fifth node wants to access some range of blocks of data from the original request, they're already in cache. And so it's going to do that. It's going to increase your pipeline throughput because ultimately, remember, if you're using object, it's not immediately consistent. The caching layer would be strictly consistent. And so whenever you copy the data into the cache, or while you're copying the data into the cache, if something in your pipeline needs to go access that data, that's an immediate request, and it will be serviced immediately. And so you don't have to put any backups in your pipeline. And ultimately, a data access layer will do this thing called cache-to-cache transfers. If I have 1,000 nodes in Google Compute Engine, and I distribute those 1,000 nodes across 5 or 6 data access cluster members, some node is going to ask for data that was retrieved by another node that may be linked to another cache member. Instead of having to go back and retrieve it from the back end, it's simply going to transfer that data over to the other cache node member, thus reducing overall latency. And all of this will have the effect of reducing storage costs. You don't have to then have worker nodes in a cluster in GCE, for example, that have large local disks, because you can simply use an NFS mount point and have everybody access, all the worker nodes access the data in that fashion.